Hi, let's continue with a discussion on the mathematical interpretation of the word of in the phrase A over B of C over D. Let's begin with a quick review of an example we discussed in details in the last video. Notice here 15 is a multiple of 3. The definition of 2/3 of 15 we said was that 2/3 of 15 is the length of two parts when a segment of length 15 is partitioned into 3 equal parts. And from the picture we can see 2/3 of 15 is 10. Now we consider 2/3 of 5, where notice 5 is not a multiple of 3. As far as the definition goes, it remains the same. 2/3 of 5 is the length of two concatenated parts when the segment of length 5 is partitioned into 3 equal parts. So in other words, 2/3 of 5, this 5 is telling us look at a segment of length 5. 3 in the denominator is telling us partition that segment into 3 equal parts, and 2 in the numerator tells us concatenated two such parts, and by definition the length of those two concatenated parts is 2/3 of 5. So let's look at how we can proceed in this situation where 5 is not a multiple of 3. So we have to be a little clever about how we partition this into 3 equal parts. So we'll proceed as we did when we did in the video for division interpretation. We look at this segment and as made up of these segments 0 to 1, 1 to 2, 2 to 3 and so on. And each of these segments we partition it into 3 equal parts. So now we can view this segment as concatenation of 15 short pieces where each short piece is of length 1/3. So in other words, 2/3 of 5 equals 2/3 of 5. I'm viewing it as 15 over 3. So I'm replacing 5 by 15 over 3. So now I write 2/3 of 15 over 3 can be thought of as 15 copies of 1/3. Now by this discussion, 2/3 of 15 is really 10. So now we get 2/3 of 15 is 10 and copies of 1/3. So we have 10 copies of 1/3. Another name for 10 copies of 1/3 is 10 over 3. And now let's look at the number line picture. So here's a segment of length 5. We can view this segment as 15 copies of a third. So those 15 short pieces can be put into 3 equal groups as follows. 5 to each group. So there it is. And if we concatenate two such parts, we get this segment, and its length it's easy to see is 10 over 3. Remember, each short piece is of length 1/3, so you can easily see that this segment has length 10 over 3. So 2/3 of 5 is 10 over 3 from the picture in this manner, and the steps can be written out in this manner. So let's take another look at 2/3 of 5th. We used these steps to arrive at 10 over 3, and I showed you the number line picture. Now let's rewrite these steps in a slightly different manner as follows. 2/3 of 5, notice here 5 is not a multiple of 3, and now here I write it as 2/3 of, I rewrite 5 as 5 over 1, which you know we can do that. Now what we do is we use fundamental fact about equivalent fractions. So you'll agree that I can replace this by 2/3 of 3 times 5 over 3 times 1. That's exactly what happened here. I replaced 5 by 15 over 3. So here I'm just leaving 15 over 3 as 3 times 5 over 3 times 1. And you'll see why in just a minute. Now in this step I write 2/3 of, notice this is really 3 copies of this fraction. This 3, I'm putting it out here, 3 copies of this fraction. So 3 copies of this is really 3 times 5 over 3 times 1. Why do I do that? Now look at this expression. I have 2/3 of 3 copies of something. this something, for a minute you can think of it as apple. And so what we have is, we have some number of copies of apples. What is it? It's 2/3 of 3 copies of apples. What is 2/3 of 3? 2/3 of 3 is really 2 copies of, whatever it is, apple. Well, now, so if you have trouble keeping track of this, you can visualize it as an apple and focus your attention on this computation, 2/3 of 3. So 2/3 of 3 is 2. So then what we have is 2 copies of the same thing. Now look at this. What is 2 copies of a fraction? That's really same as 2 times 5 over 3 times 1. And that is 10 over 3. Exactly same answer. The reason I wanted to show you this is, it will now be easy for you to see a connection between this and the final answer. Here 5, once you rewrite it as 5 over 1, notice, look at this expression. In the numerator we have 2 times 5. 2 times 5. Product of these two numerators. In the denominator we have 3 times 1. 3 times 1. Product of the denominators. So in the future we want to be able to go directly from this step to this step. So writing out all the steps shows us the mathematical reasoning, and then once you understand that, you will be able to go directly from this to this step. That's why I wanted to show you this perspective. 3/4 of 5, by definition, is the length of 3 parts when the segment 0 to 5 is partitioned into 4 equal parts. So once again, this 5 tells us, look at a segment of length 5. This 4 in the denominator asks us to partition that segment into 4 equal parts, and then 3 tells us, look at a concatenation of 3 parts. But right away we can see, since 5 is not a multiple of 4, we're going to have to do some clever trick to partition this segment into 4 equal parts. But we are now familiar with this trick. Each of these segments, we partition it into 4 equal parts. So that means this whole segment is now, we can think of it as a concatenation of 20 short pieces, where each short piece is of length 1/4. So I have here 3/4 of 5 is 3/4 of 20 over 4. So I'm regarding 5 as 20 copies of 1/4. So I have here 3/4 of 20 copies of 1/4. And as before, 3/4 of 20 is now easy for us to calculate. So 3/4 of 20 is 15. So now we have 15 copies of 1/4. Another name for that is 15 over 4. So 3/4 of 5 is 15 over 4. We see that on the number line picture. Here's the segment of length 5, which when viewed as a concatenation of 20 short pieces, and if we put those 20 short pieces into 4 equal groups, here are the equal groups. 5 short pieces in each group. And this 3 tells us, look at the concatenation of 3 such parts. And the length of this is in fact 3/4 of 5 would be this length. And we can see from the picture, each short piece is of length 1/4. So if you count up, this point is 15 over 4. The length of this segment is 15 over 4. So once again, we use the definition to do the computation. Here are the steps to write it out. Here's a number line picture where you can actually see. As before, let's take another look at 3/4 of 5 from a slightly different perspective. So I rewrite 5. I can rewrite 5 as 5 over 1. So 3/4 of 5 is exactly same as 3/4 of 5 over 1. So now here 5 is not a multiple of 4. So what I do is I use FFEF and rewrite 5 over 4 as 4 times 5 over 4 times 1. We can do that. And so now from going from this step to this step, I now view 4 times 5 over 4 times 1 as 4 copies of this fraction. 5 over 4 times 1. What does it give us? It helps us focus on 3/4 of 4 computation, because this line tells you you have 3/4 of 4 copies of something. For a moment you can think of that something once again as an apple. That just so now you can focus on what is 3/4 of 4, because whatever it is, you have that many copies of whatever that something is. Now 3/4 of 4, now you're very familiar with it. You can say is 3. 3 copies of whatever that something is, apple, a number, whatever that is. There it is. Now focus on this step. 3 copies of 5 over 4 times 1. What is that? That's really 3 times 5 over 4 times 1, which gives you 15 over 4, which is also what we had before. So the reason I wanted to show you this perspective is, notice in this expression 3 times 5 over 4 times 1, we can see a connection to 3/4 of 5. Once you write 5 as 5 over 1, notice 3, 5. Those two numerators, the product of those two numerators shows up here. 3 times 5. Denominators 4, 1. The product of those two is here. 4 times 1. So once we get a good understanding of this, we should be able to go directly from this step to this expression and then this answer. Thank you.